Alright, now we shall proceed with question number 5, which is now moving to chapter 2. So the first question for chapter 2 is the Hess law. So given to you, your target equation is NO plus O will produce NO2, and given that the three equations given to you are like this. So what should you do? In the first is that you need to look at the arrangement of the reactant and also the product of this equation given to you so that it matches the target equation. So I'm just going to write again all these equations so that we can do the necessaries. Alright, so your target equation is NO plus O will produce NO2. So given to you are three different equations, which is NO plus O3 will produce NO2 plus O2, whereby the delta H equivalent to negative 198.9 kilojoule. Right. So the second one is O3 will produce 3 over 2 O2, where the delta H is equivalent to negative 142.3 kilojoule. And the last one is O2 will produce 2O, where the delta H equivalent to positive 495.0 kilojoule. Right, so all of this matches the question. So now we need to look at the location of the product and also the reactant. So now for the first equation, we do need the NO here, and the NO is indeed at the reactant, so there's no problem with that. And for the second equation, actually there's none of this is related to this, but we are just going to just let it be at first. And then the third one is that O2 and O, but we need the O to be at the reactant, so we need to swap places for this one. Right, so since we have this O2 here, but we don't need O2 anywhere at the target equation, so one of these should be moved to the other side. So because this one with NO here means that we don't want to change the positioning over here, so therefore this equation shall need to be swapped as well, so that we can omit the O2 for this one and this one. Alright, so after you have know the position, so we just need to write again in the correct order. So the first equation is, we just have to copy the whole thing because we don't do any adjustment to the positioning of the reactant and the product, right? But the second one, because we need to twist it, so it's going to be 3 over 2 O2 will produce the O3, so delta H, because at first it was negative, so it's going to turn positive because we swap the places from the reactant and the product. The value shall stay the same, only that we change from negative to positive. So same goes with this one. We are going to change the position, so 2O will produce O2, therefore the delta H from positive we are going to change to negative. Okay, so what else should we do? So how much oxygen that we want? Actually we only want 1, right? So therefore, how to remove this 2? So we need to times 1/2. So in saying that, this equation shall be, now will be O equivalent, will produce half of the O2. Therefore, the delta H shall be equivalent to 495.0 kilojoule divided by 2, which is negative 247.5 kilojoule. Right. So here, the equation that we are going to use is this, and this, right? So this one can be omitted because we already adjust the value here. So this is the one that we are going to use, right? So now we need to slash out the things that we do not want. So if you can see on the reactant side, you have 3/2 oxygen, and here we have oxygen and half oxygen. So half plus 1 equivalent to 3/2, right? So this one we can slash, so there will be no more O2 lingering around here. So what else we don't need is the O3. So we have O3 at the product and we have O3 at the reactant, so we can slash that one out too. Therefore, we will end up having this only NO plus O, which will produce is nothing else except the NO2. So what about the delta H? So the delta H, you just need to do a summation of this, and this. Therefore, your delta H should be equivalent to negative 304.1 kilojoule. So this is the final answer. Question number 6, still in Hess Law, Chapter 2. So given to you, your target equation is 2N2 plus 5O2 will produce 2N2O5 with 3 different equations given to you to be used, all of it. So let's just copy back the questions and the list of equation given to you in the question. So your target equation is 2N2 plus 5O2 to produce 2N2O5, right? So you were given 3 different equations, which are 2H2 plus O2 will produce 2H2O with the delta H of negative 571.6 kilojoule, right? And the second one is N2O5 plus H2O shall produce 2HNO3 with the delta H of negative 73.7 kilojoule. And the last one is N2 plus 3O2 will produce, another one plus H2 will produce 2HNO3, delta H equivalent to negative 348 kilojoule, right? So now you need to look at the position of things here. So the first one, well, actually we don't need, we do need this oxygen here. So for the first one, we may leave it that way, but we're just going to check the one that we have after this. So the next one, we have N2O5, H2O, and HNO3. So definitely we need the N2O5 to be at the product. So this one need to be shifted, right? And then the next one is we have N2O2 H2 and we have HNO3. So it seems that we do need this N2 over here. Okay, but if you can see, we might have an excessive amount of O2, so therefore we need to do something with the first one. So I think we should move this O2 to the product instead of letting it be at the reactant. So we are going to swap places for this one as well. Right, so the same drill, you just need to copy again, whereby you need to put the reactant and the product at the correct positioning. So we're just going to do that. So the first one, it should be 2H2O shall produce 2H2 plus O2, and the delta H from negative, it should change to positive. Right, and then moving on to the second one, you should change the position as well. So 2H and O3 will produce N2O5, which is matches the target equation, plus H2O, and your delta H shall be positive because this one is negative 73.7 kilojoule. Right, the last one you just need to copy back is N2 plus 3O2 plus H2 will produce 2H and O3, since you didn't do anything to it, so you just need to copy the same value. Okay, so now we are just going to check again whether we have enough of things or not. So basically the first one is okay, I have no problem with this, but the second one we actually need 2 of this, right? So we need to times 2, right? And then for the third equation, so because what else do we need? We need 2 and 2 as well, so we need to times 2 over here. So again, it's just a repetition, so I'm just going to write this quickly. H2 plus O2 will be H equivalent to positive 571.6. So this one shall be 4. 2 times 2 is 4. H and O3. So you shall get this 2 N2O5 plus 2H2O. So your delta H is equivalent to positive 147.4. And the last one is 2N2 plus 2 times 3 is 6O2 plus 2H2 will produce 4H and O3. So your delta H is equivalent to negative 696 kilojoule. Okay, so now we need to look at this equation and try to get back to the target equation. So what should we do? So the first thing that you do not want is excessive amount of O2. Now at the reactant you should have only 5 O2. Now you have 1 excess, 6 O2, but if you look at here, you have 1 O2 lingering around at the product. So this one can go away, so making this 5 O2. Alright, so settle with that. Do we need water? We don't need water at the target equation, right? So since we don't need water, so we need to remove this. So we have 2H2O here and 2H2O here, so this one can go away as well. So what else that we don't need is the HNO3. Is have nothing to do with the target equation. So we have 4HNO3 here and we have 4HNO3 here as well. Okay, and then we don't need the H2. We have 2H2 here and 2H2 here. This can go away. Yep, and that makes is left with 2N2, 5O2, which will produce 2N2O5, which matches the target equation. So you just have to rewrite it. 2N2 plus 5O2 will produce 2N2O5. So you just need to do the summation of this value. You get your delta H should be equivalent to 23 kilojoules. So this is your final answer.